Hey, welcome to your favorite intermediate algebra class. We're going to talk today about graphing and solving systems of linear inequalities. That's our objective, is to graph some of these systems of linear inequalities. So let's take a look at this first one here. Graph the system. Okay, so a system of linear inequalities is just two or more linear inequalities. Okay, you notice you got a couple here. So what we're going to do is we're going to graph each of them separately, or I'm sorry, graph each of them on the same coordinate axis. Let's show that first. So if you recall, when you're graphing these things, the first thing we want to do is we want to graph the boundary line. So we make it into an equal sign. Y equals x minus 1 as, and in this case, is this solid or dashed? And if you recall, you're like, oh yeah, that's solid, right? It's a solid line, meaning all the points on the line are part of the solution set for that inequality anyways. So y equals x minus 1. So y equals mx plus b. Your y-intercept here is negative 1. Your slope is 1 in front of the x there. So up 1 over 1 from the point. Let's put that on the graph here. Y-intercept negative 1. Up 1 over 1. Up 1 over 1 and so on. Okay. And we're doing this thing solid. This is a solid line. Okay. Second thing we do is we test a point not on the line. So I'm going to go ahead and I'm going to test the 0, 0. So kind of above that line there, if you will. I'm going to plug it into the original inequality. So 0 is my y value, 0 is my x value. Is 0 greater than or equal to negative 1? And we say, sure it is. That's true. So since it's true, I shade the side the point is on, since it's true. If it would have been false, I would have shaded the other side. Okay, so there's that part of it. All right, now let's go back up. This is a system of inequalities. So now I got to do this second one on the same graph. Y is less than negative 2x plus 1. Let me erase this so I have a little more room here. Okay, y is less than negative 2x plus 1. So we graph the boundary line. Y equals negative 2x plus 1, as in this case now it's dashed line, right? Because it's strictly less than. It's not less than or equal to. So dashed line here. So our y-intercept is 1. Our slope is negative 2. So we're going to go to the y-intercept of 1, down 2, right 1, down 2, right 1, and so on. But this one is dashed. So you see my dashed line here. Okay, let me pick a point that's clearly not on that line. So how about, let's pick a point clear out here. How about 3 comma 1 is clearly not on that green line, is it? Okay, so I'm going to test 3 comma 1, plug it in, 1 for my y, 3 for my x. Is 1 less than negative 5? I say definitely not less than. That's false. So instead of shading the right-hand side of this green line, I'm only looking at, if you can ignore the blue for a minute. Instead of shading the right-hand side of the green line, it's false. I got to shade this left-hand side of the green line, okay? So the solution set, all ordered pairs that satisfy both of the linear inequalities. In other words, the intersection of these two shaded regions is my solution for this system. And can you see how they're both shaded in here? Okay, so all those points, for instance, negative 5, 0, that's a solution. Okay, a point on this solid line is a solution as well, since it's a solid line. A point on the dotted line is not. Okay, so anywhere where both regions are shaded, that's what you're looking for. That's your solution to this system of linear inequalities. Let's do another one. X is greater than or equal to 1. So we graph x equals 1 as a solid line. If you recall, that's a vertical line, right? So x equals 1, solid and vertical right there. Solid and vertical, this is our y, this is our x, right? Here's our x equals 1. We go ahead and we're going to test. Hey, let's go ahead and test 0, 0. Is 0 greater than or equal to 1? I say false. So I shade the other side. So it's all this over here. Okay, there's the first part of it. Y greater than or equal to 2. Y greater than or equal to 2. Graph y equals 2 as a solid line. Y equals 2 is horizontal, if you recall. This is solid. We go ahead and test 0, 0 again, so below that green line. Plug it into y greater than or equal to 2. Is 0 greater than or equal to 2? I say, man, that's false again. So false, that means it's the upper portion of the green line. So far you can see where the red and green is, right? But we got 3 of these inequalities. Let me erase this, give myself a little room here. Okay, last one, y less than or equal to 5 minus x. So let's graph y equals 5 minus x as a solid line. Let me write it mx plus b here. So my y-intercept is 5. 1, 2, 3, 4, 5. There's my y-intercept. We're going to go down 1, right 1, down 1, right 1, down 1, right 1, and so on, down 1, right 1. And this thing is solid. Okay, pick a point. I'm going to pick 0, 0 again. It's on below that blue line there. 0, 0, I'm testing and I'm plugging it into this. Oops, 5 minus x. Oh, that bugs me. Plug in that. Is 0 less than or equal to 5? I say, you bet, true. So I shade the side the point's on. Points below the blue line. Okay, so I'm looking for, where is it? Red, green, and blue. And I say, oh, it looks like it's just inside this triangle in there, isn't it? Okay, that's where all of those are occurring. Okay, so that's a solution, a graphical solution to a system of, in this case, 3 inequalities. Thanks for listening. Make sure you guys bring your notes to class.